So what you see there, the date going, that is from Cassini's launch. Cassini is the name of the probe that was in the Saturn system for over a decade. It took a few years to get there, so you can see the light blue is Cassini's orbit. So when you send a probe somewhere, you don't send it directly to that location. You're just seeing Jupiter there, and all the white fuzziness that you see right here, those are the trajectories of Jupiter's moons. So you notice that Cassini took a couple orbits of the inner solar system to get a gravitational boost from Jupiter. And it's approaching 2004, and you can see the Saturn system right here. So Cassini reached Saturn in the middle of 2004. Cassini is a fairly large probe. Took its friend the school bus with it. Now that was to remind me to tell you that Cassini is roughly the size of a school bus. The perspective of the school bus there was a little bit goofed up. But you can see lots of different probes on here. So there's the radar dish, and the radar dish this was a tool used to probe the largest moon of Saturn, Titan, to probe through the haze. We'll take a closer look of Titan in a bit. Titan has a lot of organic, what you could call smog. So light that bounces off Saturn, or that bounces off Titan, doesn't get out from Titan's atmosphere. So we need something other than just visible light to observe some things. This long probe here is a magnetometer. These long stiff wires are basically looking at radio waves. Oftentimes the size of the detector relates to the size of the wave that is being studied. Radio waves are long. I put the link to Worldwide Telescope and to this Saturn pack in the chat earlier. David Weigel, who's a Worldwide Telescope expert, he's the one that put this together, and I did some minor edits to it. My skill with Worldwide Telescope pales compared to his. So here we see Saturn. A couple things you notice about Saturn. The obvious thing you notice is its rings. Saturn is not the only planet with rings, and things other than planets can have rings as well. At least one of Saturn's moons has rings. The focus of our trip today is Saturn's moons, but the moons and the rings have a relationship. You notice some gaps here. In many of those gaps, there are moons, and moons also will shepherd the rings, will keep the rings stable, and moons will also feed the rings. So particles coming off some of the moons will feed the rings. All these colorful lines here, those represent orbits of Cassini. So you can see there are a lot of different families of orbits. Like this green family here, that's when it went really close and it went through the rings there. So these trips were looking at the rings of Saturn. Some of Cassini's orbits were looking at the closer moons. The gray lines here, I kind of like this weird drunken blue line. I think that might be some sort of programming glitch. But the gray lines here, those are trajectories of Saturn's moons. So you can see that most of the moons are outside of most of the orbits of Cassini. By the way, about 3 years ago, NASA purposely crashed Cassini into Saturn. NASA and the other major space agencies have rules to keep the places where there could be life pristine. Saturn is unlikely to have life. What you're seeing here, Enceladus, I guess if you had to say likely or unlikely, you might put money on unlikely. But if you had to bet on a moon, this would be a great moon to put your money on for life. So Enceladus is about the size of Arizona. So Enceladus is a swing moon. It's about 500 kilometers across. One of its most interesting features, these green stripes here, they're nicknamed the tiger stripes. And those tiger stripes are places where the inner ocean of Enceladus leaks out. Enceladus is a shell of ice. Most of the shell is on the order of 20 kilometers thick. But where these tiger stripes are located, the shell is about 2 kilometers thick. So that's where the undersurface ocean of Enceladus is spewing out geysers. And we know that because of Cassini. Cassini passed through those geysers and analyzed the material, and it was water material, but also some organic material as well. Carbon dioxide, methane, some salts. Those geysers shoot up at about 800 miles per hour, which I just realized I look at my notes here on occasion. I'm trying to use metric system, so I said 500 kilometers across, but then I realized I put 800 miles per hour. That would be about, I think, 1,500 kilometers per hour or so. And the geysers in Enceladus that come out of Enceladus feed one of the rings, the E ring of Saturn. You see that there aren't that many craters on Enceladus. That's because it is geologically active, and the water that spews up will cover those craters. So we're going to visit Titan next. This picture here is on the surface of Titan. Along with the Cassini spacecraft, there was the Huygens probe. NASA and the European Space Agency worked together. NASA's focus was Cassini. The European Space Agency was the Huygens probe, which you see there. And it landed on Titan. Those cables that you can see actually was holding a parachute. And if you've read stories or watched videos about the landing of spacecraft on Mars, you might know that spacecraft on Mars have a hard time landing with parachutes because the Martian atmosphere is so thin. That is not the case with Titan. Titan has a very thick atmosphere. Titan's atmosphere is about 50% thicker than the Earth's. It's primarily nitrogen with a little carbon dioxide mixed in there as well. So you might say, object with a pretty thick atmosphere that's mostly nitrogen, what does that sound like? Well, if you think that it sounds like something close to us, let me also tell you that Titan has a fluid cycle, like we have a water cycle on Earth. Titan has a similar cycle, although it is a methane cycle. So there are methane lakes on Titan. And up here, put my little cursor there and you can see the menu show up. But the northern part of Titan near the North Pole is called the Lakes region, kind of like the Great Lakes on Earth. Titan's lakes are a few hundred meters deep, and a few hundred meters deep and a few hundred kilometers in size on average. So similar to the Great Lakes. The color that you're seeing now is a topographic map where blue is the low-lying areas and orange are the higher areas. The next moon here, and by the way, Titan is the largest moon in the solar system, roughly the same size as Mercury and much bigger than our moon. Mimas is the smallest of Mercury's innermost moons. It's about 400 kilometers across, and it orbits Saturn once an Earth day. So it takes about 23 hours for Mimas to orbit Saturn. It is mostly water ice, so it is a crater-filled icy ball. It does not, at least astronomers think, it does not have an undersurface ocean. And you're looking at some of the major clues for that. Planets that have undersurface oceans and that leak out are smoother. Mimas is heavily cratered. And you can see right here, this huge crater. This is the Herschel crater. This crater is 130 kilometers across, so about 40% the size of Mimas. And this is the thing that hit Mimas here that made this crater. That's at about the limit of what would have destroyed Mimas. Anything larger than the item that made the Herschel crater would have broken Mimas apart. And that crater there is about 5 kilometers deep. And when you think it's only 500 kilometers across, the depth of that crater is about 10% the size of Mimas. So Tethys is the 5th largest moon, about 1,100 kilometers across. It has a lot of craters as well. So it's primarily ice with some rock. It has two large craters as well. There's a large crater in the in the northern hemisphere, and a large crater in the southern hemisphere as well. You can see Saturn in the background. And Tethys, by the way, like most of the major moons of Saturn, are tidally locked, which means the same face of the moon, same face of each of those moons is towards Saturn. And if that term sounds familiar, tidally locked, our moon is tidally locked with the Earth. If you look at the full moon each month of the year and sketch it, you'll notice that it always looks the same. This moon is the one I always have trouble pronouncing. And when you look it up, lots of different pronunciations. The one that I found the most recently, because I thought I should see if there's more of a consensus, is Dione. But I've also seen, Dione. This one, obviously, a lot of craters again, you can see. This is roughly the same size as Tethys. What's different about Dione compared to some of the other moons is it has a large, compared to Dione, rocky core. So it is sort of like a candy with a hard, super hard center, one of those hard centers that you might chip your tooth on. So you bite through the ice of Dione, and then you hit this rocky core. Dione is roughly the same distance from Saturn as our moon is from the Earth, but Dione takes only 3 days to go around. Rhea is Saturn's second largest moon. It's about 1,500 kilometers across. It is roughly 3/4 ice and 1/4 rock. And as opposed to Dione, Dione is pretty well differentiated with a rocky core and then the thick icy shell. Rhea is more like a dirty snowball. Remember if you ever had snowball fights as a kid and you snuck some little pieces of rocks in the snowball? That's what Rhea is. Rhea and Dione have, so you can see some of these wispy cracks here that are really deep, many, many hundreds of meters deep. And those there are lots of ideas for how those formed. They could be cracks with just the settling of the moon. I mentioned before about the rings. Rhea has a very wispy ring around it. Iapetus is one of the most interesting looking moons. It's the third largest moon, about 1,500 kilometers in diameter, a little bit smaller than Rhea. It is also 3/4 water, ice, 1/4 rock. And I read when I was doing some research, it's called the yin yang moon. You've seen that yin and yang symbol with the white and the black. The leading edge of Iapetus is the dark side, and the trailing edge is the light side. One idea for that is that the leading edge is maybe picking up particles from another moon. So it's like you sweep a clean rag across a dusty surface, and your rag picks up dust. Another idea is that there is, because that looks fairly smooth as well, that there are volcanoes that are bringing up dirtier, darker particles from underneath. Hyperion is the largest of Saturn's irregular shaped moons. Kind of looks maybe like an almond with a big dent in it. Astronomers think that it's the remnant of a larger moon that got destroyed a long time ago, because it's sort of in that size. It's not super tiny and almond shaped. Oh, it's almond shaped. It's not super tiny, but it's not nearly as big as those other moons as well.